Welcome back to Air Quality Matters and One Take. One Take, my take on a paper or report on air quality, ventilation and the built environment. One Take in that it's, in one take and tries to summarise for you a scientific perspective on something interesting in, usually 10 minutes or less, because who has the time to read all these amazing documents, right? This week, I'm looking at a paper that's titled A Review of the Indoor Air Quality in Residential Passive House Dwellings. And it's by Gabriel Rojas and his colleagues Martin Fletcher, David Johnston and Mark Siddle. Published in the Journal of Energy and Buildings. The central question is interesting. We hear about passive house standards as the pinnacle of energy efficiency, comfort and supposedly indoor air quality. But does the reality match the claim? When you build these incredibly airtight homes and rely on mechanical ventilation systems, are you actually creating a healthy indoor environment, or just sealing people into well-insulated boxes with its own set of problems? The paper tries to answer that by looking at the evidence from hundreds of real occupied homes. So what the authors have done here is a comprehensive review. This isn't just a handful of case studies. They've synthesized the results from 35 different measurement studies covering more than 600 passive house or passive house-like homes. And crucially, they've dug into what they call the grey literature, a lot of German language reports and studies that often get missed in the English language reviews. So it's a really thorough look at the state of play. Let's start with the good news, because there's plenty of it in the paper. The paper confirms that on the whole, homes built to the passive house standard generally have lower concentrations of carbon dioxide, VOCs, and radon compared to conventionally built, naturally ventilated homes. This isn't a huge surprise, of course. A balanced mechanical ventilation with heat recovery system or MVHR system is designed to run continuously, supplying fresh air and extracting stale air. And when it's working correctly, it does this job very well indeed at diluting those background ventilation pollutants. But here's where it gets interesting, and this is a massive takeaway. The paper makes it very clear that it's not just about having an MVHR system. It's about having one that is designed, installed and commissioned properly. The authors differentiate between certified passive houses, declared passive houses and other homes with MVHR. And the results are stark. The paper highlights a UK meta-study that is incredibly telling. It found that 100% of the certified passive house dwellings they looked at provided the required supply airflows. Now compare that to the other non-certified homes with MVHR, where only 47% met the requirements. And let's be crystal clear about what that 47% compliance rate means. This wasn't a failure against a super high passive house standard or something. This was a failure against their own local building regulations. This means over half of these installations failed their own basic compliance test from day one. So what we're seeing isn't just a performance gap, it's a systemic pathology in a wider construction industry. The paper's data strongly suggests the real value of the passive house certification isn't just in its ambitious targets, but in the mundane procedural rigour and quality assurance that ensures that those targets are actually met. Without that quality control, you're effectively rolling the dice on whether your ventilation system works at all. However, it's not a perfect picture. And the paper is very clear about the challenges. One of the biggest ones, by far, is particulate matter. This is a real kind of gotcha, really, in the paper. The review points out a major historical blind spot, cooking ventilation. Here's the problem in a nutshell. Multiple studies found that even in perfectly performing passive house homes with low CO2, cooking could cause drastic spikes in harmful PM2.5 particles. The root cause is a lack of specific requirement in the standard for effective source capture in the kitchen. In the drive to conserve every bit of energy, the tendency was to install recirculating cooker hoods. These hoods are not a solution. They just capture a bit of grease and odour, but the fine and ultrafine particles that pose the greatest health risk are pumped straight back into the highly airtight living space. Crucially, the whole house MVHR extract grill in the kitchen is not a substitute. It's designed for low continuous background ventilation. It simply doesn't have the high flow rates or capture efficiency to deal with the intense short-term plume of particles coming off the hob. So in an airtight home, these particles effectively have nowhere to go and can hang around for hours. You end up with the paradox of a healthy low CO2 home that potentially has dangerously poor air quality every time someone cooks. The authors are very clear this needs attention, though they do note the Passive House Institute has since published new guidance to address this very issue. So, as a quick aside to the paper, what is this new guidance? Well, one, strong preference for extract hoods. The updated guidance now strongly recommends extracting cooker hoods that vent to the outside as the most effective solution for removing harmful cooking fumes. Number two, an emphasis on airtight and thermal bridge-free design. So airtight dampers are essential. The duct to the outside must be sealed with a high-quality motorized and insulated airtight damper. This prevents air leakage and heat loss when the hoods are not in use. Standard flimsy backdraft dampers are not sufficient. And thermal bridge-free ducting. So the ducting that's penetrating the thermal envelope of the house must be detailed to be thermally bridge-free, preventing localized heat loss and potentially condensation issues. Number three, a requirement for balanced ventilation makeup air. A crucial part of this new guidance is the requirement for a balanced system. When an extractor hood expels a large volume of air, an equivalent volume of fresh air must be supplied to avoid depressurizing the house. This makeup air should be controlled and interlocked. So the makeup air should be controlled and interlocked with the operation of the cooker hood itself, and pre-tempered if necessary. So in colder climates, the incoming air may need to be pre-tempered to avoid comfort issues and drafts. And number four, guidelines on hood design and placement for efficiency. So to maximize the effectiveness of the extraction and minimize the required airflow, the associated energy loss effectively, the guidance provides specific design and recommendations. And finally, number five, integration with passive house planning packages, PHPP. The energy implications of these more powerful extracting kitchen ventilation systems are now explicitly accounted for in the Passive House Planning Package, the primary energy modelling software for passive house design. This allows designers to model the energy use of the hood and the associated heat loss from the makeup air, ensuring the overall energy balance of the building still meets the strict passive house standard. And what about recirculating hoods? The guidance acknowledges that in some specific situations, such as very small apartments, typically under 90 square meters, or in retrofits where external ducting may not be feasible, a high-quality recirculating hood might be the only option. However, it is understood this is a compromise and will not effectively remove PM2.5 particles. In such cases, other mitigating factors, like opening windows, may have to be considered. I think that will come as quite a surprise to some people in the passive house community. So, to wrap it up, what's the final verdict from the review? The passive house approach can deliver excellent indoor air quality for background pollutants like CO2 and VOCs. It generally outperforms conventional housing, which is no surprise. The continuous balanced ventilation strategy, when done right, really works. But there are two huge caveats that this paper drives home. First, when done right is the key phrase. It provides powerful evidence that certification and its associated quality assurance are non-negotiable, highlighting that many standard ventilation installations are simply failing their own requirements. Second, the standard has had a historical blind spot around cooking generation of particulate matter, which can create significant risk if not addressed with proper source capture extraction. Ultimately, this paper is a brilliant reminder that a standard or technology is only as good as the real-world implementation. It's a call for rigor, for quality control, and for looking at indoor air quality as a holistic system. One where you can't just look at a CO2 monitor and declare victory. You have to consider everything, especially what's for dinner. Thanks a million. I hope you enjoyed this episode of One Take. This episode isn't possible without the sponsors, so thanks a million to Safe Traces and Imbiot for making it happen. See you next week.